Okay, 10.1 Convergent and Divergent infinite series. It says, recall writing terms of a sequence is written as a sub n is equal to 1 plus negative 2 to the power of n. And then you're given some series based upon what n is. So for example, if n was 1 and we were to plug in 1 here, we would have 1 plus negative 2 to the first power, which is negative 1. This is our first number. Okay, we would plug in 2, so this is us plugging in 1, okay, to get negative 1. And this is our first term. We would plug in 2 to get 5, and this is our second term, so on and so forth. Okay, this concept right here is an Algebra 1 concept. You should have learned at the very end of Algebra 1 if you took Advanced Algebra 1. Okay. You were just introduced to sequences in series. You never went into depth with them. You were just introduced to one specific sequence, and that was the geometric sequence, which we'll talk about in the next notes. So it says a sequence is a collection of numbers that are in one-to-one correspondent with a positive integer. This is just another example of a sequence, which means there is some formula, a sub n, that forms a relationship between all of these numbers. There is such thing as a monotonic sequence, which means that the sequence never increases or decreases. And there's also a bounded sequence where some a sub n is either less than or equal to m, the upper bound, or greater than or equal to n, the lower bound. For infinite series, this gives us the formula, the summation of n equals 1 to infinity of a sub n. So what that means is we plug in 1, 2, 3, etc., and they're adding them all together. Okay, this is different than partial sum. Partial sum, S of n is equal to a plus 1 plus 2 plus 3. All of those are talking about either a sequence or a series. So giving the formal definition for a sub n, it says an expression that gives the nth term in a sequence. So a sub n is always going to be one number. Okay. S sub n is an expression that gives the sum of the first n terms. So looking at the first example, it says use the following sequence 2, 4, 6, 8, and 10 to find a sub 4 and s sub 4. So a sub 4 means the fourth number, and that would be what? 8. That's the fourth number. If we're counting starting at 2, okay, this is 1, 2, 3, 4. Okay, 8 is the fourth number. S sub 4 is the summation of the first four numbers. So sum of first four numbers. So that would be 2 plus 4 plus 6 plus 8, which gives us 20. Okay. So this first part right here is just review. Okay, now we're connecting it to calculus. So remember, another way to write a summation is using the limit. So the summation as n equals 1 to infinity of a sub n is the same as saying the limit as n approaches infinity of s sub n. Okay. That is going to lead us to the definition of convergent and divergent series. So it says for an infinite series, the nth partial sum, s sub n, is equal to the following. So adding all the nth terms together. If the sequence of the partial sum is convergent or converges to s, then the series also converges. So this is a direct relationship. Okay. The same is for diverging. So if s sub n, which is the partial sum, diverges, then the series also diverges. Okay, which means we could use the partial sum, find if the partial sum converges or diverges, and then based off this definition say because of the direct relationship, if the partial sum converges, then we know the series will converge. So for number 2, I'm going to show you both. I'm going to show you how to find it using the partial sum and use it using the series. Okay, so number 2 says does the series converge or diverge? So we have the summation where n is starting at 1 to infinity of 1 over 2 to the nth power. So I'm just going to divide this in half because I'm going to show you 2 different ways. Okay, so the first way is using the partial sum s sub n. So using the partial sum, I'm going to start with s sub 1, which means I'm going to plug in 1 into n. So this is 1 divided by 2 to the first power, which is 1/2. Okay, and we typically do this for at least the first 4 or 5 summations. So I'm going to do S2. So for S2, we take the previous one, 1/2, and we add it to 1 over 2 squared. So now I'm plugging in 2 for n. So this gives me 1/2 plus 1/4, which is 3/4. Okay, remember this is a continuous sum, so we're always adding the previous one to the next. For the third one, we're going to start with 3/4, and then we're going to add 1 over 2 to the third power. So now we're substituting 3 for n. And this gives us 3/4 plus 1/8, which is 7/8. And then just doing this one more time, starting with 7/8 and adding 1 over 2 to the 4th power, we get that this is 7/8 plus 1/16, which is 15/16. So looking at all of these numbers here, okay, what do you say that these summations are approaching? 1. Okay, so they're approaching 1, so they're getting closer to 1. And since it's getting closer to 1, would this be converge or diverge? Converge. How do we know if it's diverge? If it was going towards infinity. Okay, so this one's going to get closer and closer to 1. So if we continued this, we would just approach 1. We wouldn't go past it. Okay, for diverge, we're going to rapidly increase so fast that we're eventually, if we do this as n approaches infinity, going to approach infinity ourselves. And you'll see that in one of the next examples. So that's one way. So the other way is doing the series. So that is the summation notation. And so here we can write that S sub n is equal to, and we kind of already solved it over here, but we're just putting it in terms where we're changing n. We're not going to simplify it. So this is 1 over 2 plus 1 over 2 squared plus 1 over 2 to the third, all the way to 1 over 2 to the nth power. So if we were to try to find S sub n, that would be us plugging in that n into the exponent, leaving us with some value 1 over 2 to the n power. Okay, we can take out the 1/2 that's in the very beginning. And when we do that, all of the nth exponents are going to increase by 1. So that means this is 1 over 2 squared as our starting value, plus 1 over 2 to the third power. And then if we continue that, since we're adding 1 to the n, this is 1 over 2 to the n plus 1. Okay, then we're going to take those two equations that we created and we're going to subtract them. So S sub n minus 1/2 S sub n. If we subtract these two, notice that all of this here is what they have in common. Okay, so all of this part's going to cancel out, and all of this part is going to cancel out. which means we are only left with 1/2 minus 1 over 2 to the power of n plus 1. Okay, we can then take out a GCF of s sub n, and we're left with 1 minus 1/2. And so this is s times n times 1/2, is equal to the following. And then to get rid of that 1/2, we can multiply everything by 2. And we get s sub n is equal to 1 minus 1 over 2 to the nth power. And we know that we can rewrite the summation as a limit. So we can say the limit as n approaches infinity of s sub n is going to be equal to, and if we plug infinity here, which is on the denominator, that means this entire fraction is going to approach 0, right? If your denominator increases rapidly, you're slowly approaching 0. So if this is going to approach 0, that means we're left with 1 minus 0, which is 1. And since this is approaching 1, this also proves that this is converging. Okay. So 2 different ways to show this. Notice on the right, when we are looking at the series, we are just manipulating the problem so it looks like this. Okay, we didn't alter it in any way. We're trying to manipulate it so when we took the limit as n approaches infinity, we got something that approaches 1. Okay. Any questions on 2? This part, right? This part? Yeah. So if we were to plug in infinity, so like 1 over 2 to infinity, that value on the bottom is going to increase rapidly. Okay, so let's say we have like 1 over 8, and then it goes like 1 over 16, and then 1 over, do you see how the fractions are getting smaller and smaller? That's how we know that this is approaching 0. Mm-hmm. Okay, so remember in the beginning of each unit, it's kind of building us up to what we're going to be able to do towards the end, and that's going to be Taylor series and Maclaurin series. But in order to do that, with our calculus application, we have to understand the basics. Okay, so number 3 says use a calculator to find the partial sum s sub n of the following series. So if it says use a calculator, you're literally just going to plug this into Desmos. Okay, so everyone should have Desmos open. And notice how it wants us to find s sub n for n equals 200 and n equals 1,000. So we're going to plug in those values separately. So instead of putting the infinity at the top, we're going to put in 200 or 1,000. Okay, so starting with this, you can type in SUM for the summation to pop up, or you can find it under functions. N is 1, and we first want to find when n is 200, so I'm going to say it goes up to 200. Okay, then I'm going to write the equation here. So this is 10 divided by n times n plus 2. And then notice right away it gives us our answer. So when n is 200, the summation, or s sub n, is equal to 7.45. Okay, so on my notes, that's what I'm going to write. I'm going to say n equals 200 means that s sub n is equal to 7.45. Remember, this is the partial sum. Okay, then what we're going to do again is we're going to change. This is the only thing we're changing to, is that number at the top. We're just going to make it 1,000. Okay. So n is equal to 1,000 implies that s sub n is equal to 7.49. So if you can increase in, what you're going to notice, and you can mess around with Desmos and keep increasing that in value, what you'll notice is that this partial sum is eventually going to approach 7.5. Okay, it will never go higher than that. And so if it asks you for the partial sum, that's all you need to do is go straight to Desmos, plug it in, and then write your answer. So our next part here says, does the series converge or diverge? So remember, it does not matter which way you choose to do. I think that using partial sums are easier. So that first method that we did. Okay. So doing that, I'm going to start with S sub 1. So S sub 1 means I plug in 1 for n, which is 1. S sub 2 is I'm bringing the 1 down and I'm adding when I plug 2 into n, which is 3. And then I'm going to keep doing this just for the first 4 or 5. Okay, so 3, plug in 3, that gives me 6. Bring the 6 down, plug in 4 for n, which is just 4. This gives me 10. And let's say I do this one last time, S sub 5, this gives me 10 plus 5, which is 15. So looking at all these numbers here, would you say that this is approaching 1 or infinity? Infinity, which means this is going to converge or diverge? Diverge. So closer to infinity implies diverge or diverges.